Hello there. Let's solve a quadratic inequality. I'm going to start by graphing it. So there's the axes. Now let's do this one first. That is a parabola that is centered, and its y-intercept's at 5, and it's really, really steep, and it's opening down. So I think it's going to look something like this. And the next one, y equals negative 18x, that goes through 0, 0, and it's also super, super steep. Okay, so this is just getting us an idea. I don't actually know where this point is, or if this point, it looks like it's at, like, I don't know, 2 or 3 comma negative 12 or so, but this wasn't exactly to scale. I'm just getting eyeballs on it. So let's move over. That was our first part where we graphed it. We're doing GA here. So we're going to graph, and now we're going to move on to algebra. I'm going to solve for the intersections first, where you set them equal. That's going to get me this point here and this point here. And the only way, it's a quadratic. We got a's and, well, this isn't b yet, but we got x squareds, x's, and constants. So let's get everything to one side. Suppose I could have actually moved to the other side to get rid of the negative 8x squared. Alright, now let's do the RS method. So taking the product of the a and the c, I get negative 40. So what multiplies to negative 40 and adds to positive 18. And this one's not the trickiest thing, because you start with like 1 and 40, that's not going to do it. 2 and 40, or 2 and 20 actually will, if it's positive 20 and negative 2. So then we'll split it up. Please note that I'm still writing the equals 0 here. This isn't being tacked on later. And now let's factor those different parts. So the first one, we can pull out a negative 4x, and then this next one, it doesn't look like I can factor anything out here, but I need it to become a positive 2x minus 5, so I'm actually going to factor out a negative 1. Boom. Okay, so both of these have 2x minus 5 in them, and these are the bones. And I'm going to factor out the negative 1 from this one over here, so that becomes 4x plus 1, and that negative 1 can just go on the outside there. Alright, and this is going to help me solve it. So either this is 0 or this is 0. And both of those are just linear equations, so move the 5 over, divide by 2, and you get positive 5 over 2. And over here, move the 1 over, you get negative 1 divided by 4, negative 1/4. So that's where those intersections are. Way over here, we're going to have this one at negative 1/4. And this one down here, that's going to be at 5 halves, or 2.5. Now comes the second part, the third part of GA. We graphed over here, G, GA. We did algebra here. So solve for those intersection points, and now we're going to analyze, referring back to our graph. And we want the region where this line here is above that parabola. And that's going to be here. Everything there, everything less than 1/2, that line is above the parabola. And where else is that line above the parabola? Oh, I need to extend the parabola. So the parabola goes to negative infinity faster than the line, so after 2.5, it's also happening. So that's going to give me the regions. So in the number line, I get that, and this can be expressed as x is less than or equal to, right, negative 1/4, or x is greater than or equal to 5 halves. So that's part of the solution. That's the inequality form, where it's either this region less than negative 1/2 or this region greater than 5 halves, or 2.5. We can also write this as an interval notation. So First part's negative infinity up to negative 1/4 with a hard bracket on negative 1/4 because it can be that value, unioned with, it picks up again at 5/2, and that goes on to infinity, and infinity gets the soft brackets. Okay, thanks for watching. Character and Scholarship for Life.